So this is one simple problem in Cascode Amplifier. So the parameters are given. They are asking us to find the overall gain, voltage gain, current gain, all the 4 parameters as usual we are going to find. So first we will find the input impedance. Input impedance of first stage is common emitter amplifier, which will have HIE value. So HIE is 1.1K. And the second stage, you know, Ri2 is HIE by 1 plus HFE, so it is 21.56 ohms. So overall input impedance means everything is in parallel. So Ri1 parallel to Rb. So Ri1 parallel to Rb. Rb is parallel to R4. So 1.1K parallel to 200K parallel to 10K. So the answer is 9.1 kilo ohms. So because of all these biasing resistors, my input impedance is reducing from 1.1K to 986.1 kilo ohms. Please understand that. Now current gain. For common emitter amplifier, the current gain is beta. Beta is 50. So it is minus 50. Minus 50 just for phase shift. And for the second stage common base, the current gain is beta by 1 plus beta. It is 0.98. It is the value of alpha. Okay. So when you find the overall current gain, AI is equal to I naught by IS. So multiply all the terms. So you get the current gain to be minus 43.9. So individual current gain is minus 50 into 0.98, including the other values, you get 43.9. It will be approximately multiply 50 and 0.98, you will be getting close to this value. That's how you can cross check your answer. It is effectively the product of two current gains, minus 50 into 0.98. Okay. Voltage gain for the first stage, you find AV1 equal to AI1 into RL1 by RI1. So you get minus 0.98. For second stage, you get AV2 equal to AI2 into RL2 by RI2. So it is 136.36. The effective voltage gain is multiply both. 136.36 into minus 0.98. So you get minus 133.63. With source, you have to additionally multiply by this because of voltage division technique. Ri by Ri plus Rs. Minus 66.35 is the gain of your Cascode amplifier. And finally, input output resistance of first stage is infinity. Output resistance of second stage is also infinity. If you consider RL, the output impedance will be equal to RL. Otherwise, it is going to be infinity.